Where it be? Where this? Ah, low latency indeed, but it's black. Aha, copy URL. Get that shit out of here. Another session of the Refactor. Gotta get this shit done. Yonk. Boom. That means it's official. Yeet. Alright, get the chat open again. We're in IRGen. Officially. With only a handful of things left to do before we have to debug everything. Okay, so top level node declared type. We need convert type to take in a type. And then type node kind. We don't actually care about the mutability qualifier. Type node type function type. Everywhere that we have type arrow. We've done this before. Everywhere that we have type arrow. Oops. That's the wrong button. There was an undo that motion. Regular dot node. There we go. Then. So here, this type, parameter types, is a parameter node type, convert the type, parameter node, parameter type, that's technically wrong. I hate having conversions between two things and they all use the same name. I'm just going to call it PT. Boom. Function return type, node, now we put a null. Okay, that's convert type. All the types we currently have supported. Convert type takes in Laye qualified type. Then convert to C string node kind. Then declared type. Convert type. We use the declared type anywhere else? We don't. Okay, then. Type is no return. Node or condition. That just sounds wrong. I'm pretty sure this is Laye type is condition is no return type. And that was a bug. And since it's a type, node type or condition type. Well, condition arrow, all type. Come on. Okay, that may have been a bug. Type safety, everybody. Can't wait to use variants. If I could use inheritance in this AST for type safety reasons, I would. But I am not. I'm actually... I could hop in the voice chat. So I've been thinking about hopping... I have a streaming voice chat because reasons, but I've never used it. Maybe I plop on a headset, see if anybody wants to chat while we refactor. Booga. Doing shit now. Boom. If you do want to talk in Discord, there's also a live text channel. All right, cast. Both of these need to be type, like that. Of course, now I've made it hard on myself. If people are talking in Discord, I have to switch between the two. You can't see my other screen, but I can, and there's two windows now. Bit of a problem. So casting. The cast type is fine. I think all that's fine, actually. array type. And this needs to use Laye type is array of this that. And array type node type node type container. A length value is a node. Laye array type node type container length values. That's it for IR gen. That was quick. So beyond that, I don't think anything code gen related has. No. Where are we missing things? Okay. So hold on, let me get knob open and see if I can. Let's see what my command. Build does build all. I don't have a build for just the compiler and not the test runner. So if it says build, if it says YSC, actually, if it's a build command, we can then say const car what to build is not shift args argc. And does this error? It does, it asserts. If argc greater than 0, let's just build all. Then if 0 is equal to stir compare YSC, what to build, then build YSC thread. Else, return 1 probably. I don't think I have anything going on. Return 1 and f standard error. Invalid project specifying to build. I should probably remove this, make this bigger again. Try that. I got a song stuck in my head that I wanted to listen to. Don't think it's a good idea. Need a new line. Cool. So then, if I run knob build YSC, we only get the compile errors once. Hello there. How are you? Oh, 2 people. Hello, both of you. I'll have to learn how to pronounce Redon, Cardi, and Fonta. Hello. Wow. What are we wowing? So context. Oh, I have not fixed anything in context. That's probably gonna be fucked up. Red 1. Redone. Red 1, redone. Red 1. Did send at the same time, yep. Okay, so my type, instead of saying null here, this should just be 0. But it needs to be, actually, no type. I think it was a thing that I had it somewhere. But I don't have it here. So no type. The type here is context types type, which is LTI. That's fine. So then here, beep, beep. Of course, as soon as I start doing something, people want to talk to me. Let me see if it's important. It is not important. I will probably still read it. That's my email. That's not what I want. Okay, so then here, everywhere that we use this, specifically this, let's LTI. Oh my god, it's going off. Uh-oh. Oh no, I see. Okay, so then up here, LTI of LTI. Oops, didn't catch that case. Then this one is LTI of this. So right now we're just doing a refactor of my primary compiler. This is incorrect. But if you guys want to talk anything, ask any questions you want, I will still explain it. Yes. I mean, no. I guess ask a question. No, I don't mind. Don't ask to ask questions usually. Just ask the question. Worst I could do is say, no, I won't answer the question. Best I can do is just answer the question the first time. That's that. No problem. Clear. We're going to keep it clear so it's easy to scroll through because I'm a scroller. Analyze node. Incompatible pointer type. Laye type pointer to parameter of Laye node. Oh, yes. Okay. That is a problem. So that's back in Sema. Not an obvious error, but that is an error. 265. This needs to be Sema analyze type. Anywhere that I've started analyzing a type. 327. And that means it doesn't need no type. So 327 doesn't need no tie, needs to be analyzed type, which also needs to happen here. I feel like almost everywhere I use no tie is gonna be for types, so that might be a good thing to find. Clear build, that's progress. Okay, Sema 441, same thing. That is Sema analyze node type. Aha, Sema analyze type. That's a good one. I'm just finished rewriting the front end of my compiler and struggling with memory management. How do you deal with dynamic arrays? Very simply. Let me look at that real quick. Let's open in Laye, I believe it's LCADS. So a dynamic array for me starts with a header, has some information about what's allocated, and I just return a pointer after the header. Easy as. To allocate a dynamic array, it's either malloc or realloc. I could simplify this down to just use a realloc everywhere, but yeah, I didn't give a shit. It's just allocating memory here. Whenever it's resized, it's realloc, which automatically frees the previous memory. Right, so it's just using regular allocators, and it's using the auto-free properties of realloc. And anytime I'm done with a dynamic array, it just gets deleted. So here's types. Where's my dynamic arrays? Array free. I just have a function that calls free right here, which just, if it exists, sets everything to 0 so I don't accidentally use technically valid data from a freed thing, frees the pointer and sets the pointer to null all in a macro, so I can't accidentally use any of the data anymore. Easy as that. Malloc, realloc, and a free thing that automatically nulls and zeros everything so that no memory leaks. Nothing fancy. Absolutely nothing fancy. Now, something else you might want to know about memory management is everything that's not a dynamic array, and for that I use a pool allocator. So I have allocator functions to wrap the standard library allocators. They're nothing fancy, it's just allocate, deallocate, and reallocate, and the only implementation I'm using right now is standard library, so you can ignore that part. But then we've got pool or arena allocation. I called it a pool in Hibiku on accident, and I'll probably make a correction on that next time, if you've seen those videos. It's not a pool allocator, it is an arena allocator, and I mislabeled it. But an arena here is just some chunks of memory with a size and capacity. That's it. And an arena is an array of blocks. And all you do in an arena is continue allocating to the end of the arena, make a new block, continue allocating to the end of the arena, make a new block, and then you just free the entire arena all at once, like a garbage collector. Except you're collecting all the garbage all at once. So the API for an arena is just push memory, which gives you a void pointer, you know, the memory that you allocated for the size. Clear, to just, there's your deallocate. And everything else is create the arena, destroy the arena, which we'll call clear and like free and stuff, and then dump just tells you how much you've allocated. Yeah, for the dynamic arrays, I decided they don't need to be linked to the arena in any way, really. because they're going to be allocating and reallocating, and that would super fragment the arena. The reason we're using the arena is because everything we allocate we probably care about and we're never going to be freeing from. So dynamic arrays don't come out of the arena. They just come out of regular heap memory without any intermediary. And that's it. That's all I do. Those two constructs get me all of my memory management in the entire compiler. So pretty good, pretty good. We were in Sema. 441, I think, was fixed. Yep, so 414, 476. Do it again, because that's not a good line number. 476, incompatible pointer type. I did 473, that's why. This one is analyze type. Then 1342. Analyze type. Are you familiar with object declaration stuff? I'm using Python with YOLO v5 on a custom dataset, but it is not training correctly. I have no idea what any of that means, so I'm going to go with no. I assume you're training a neural network or something, and no, I don't know. 1353, that's down here. And then this. Okay, thank you for pointer, incompatible pointer types. I need something that returns a value there that'll have to get fixed. 1367. Element type. And the other thing is actually a value, I believe. Like value, yep, cool. So then non-void function does not return a value. That needs to be like added to knob. Hold on. Why do I keep doing that? I know it's fucking knob.c, so I can just... Okay, C flags. We always want knob command append command W return type, right? W return type. That should just exist. That should be an error. That's W. Error equals return type, question mark? There we go. Okay. So now non-void function, Sema 421. So not node is... What? Non-void function does not return in all control paths. 412, but 412, not 421. So 412 is here. I just typoed. 412, Sema analyze type is supposed to return a bool. So it should bool result, which I guess should just be if not this, return false. And then just return true. Thinking of using virtual memory for dynamic arrays, the idea is to virtually deallocate a big chunk of memory and keep committing parts from it as I need them. Get rid of reallocation problems. Probably. Yeah, I mean, that sounds like it would make sense, but I don't know that I would care about it that much myself. If you could build out an example and stress test it and it actually looked promising, then by all means. But I might not over-engineer it that far unless you have the tests and the validation that it's worth it, personally. All right, it builds. If I do my tests, do the tests pass? Hey. It's not really complicated stuff. Memory is memory. It's just an array of bytes and you get a pointer to it. The virtual memory is just memory that doesn't exist yet, and your operating system decides where it is when you want it. So you just don't think about it as... It's literally just the same thing from your perspective. If that's the two things you're talking about, then meh. It's easy stuff. If you have any specific questions about it to clarify, by all means ask. But anyway, that looks like it's... I think the refactor of 11,000 lines of code worked on the first try. Because the only failing test is the thing I'm in the middle of working on, which is structs. Working on structs is what got me to do the refactor, so it never passed in the first place. So Now that we're here, cannot index type vec2i pointer mute. So why do I have a pointer here? Oh, because it's a name type. The name type is pointing to the thing that it's naming, I think. So all of these 3 pointers are the same because it should be the declaration pointer. Why am I doing that? I don't know. I think that's for syntax tree purposes. But anyway, so now I can clear knob, run AST, test Laye, and we're not going to get the AST because we're going to get this. If I did syntax, it wouldn't show up probably. So, I mean, cool. So cool. Git git. I'm going to add lib star again, git commit and add a message. Finish qualified type refactor, and I forgot to put my useless tag at the beginning because I don't actually differentiate anything like I'm supposed to. Push all of my refactor work, and we're back with this test. So cannot index type vec2i thing. Compilers are interesting. Programming is interesting. I'm glad you find it interesting. Well, now we can take a look at the example file I'm working with. Struct.Laye. What the fuck? Struct.Laye. We're trying to make this file compile. So most of the Laye compiler source is public. I forgot to put it back in the description. Let's go to github.com /Laye. Kaboom. I'll re-add it to the description. Save. Oh. And we just committed a minute ago. There's all of our stuff. The formatting. What the hell? GitHub. Okay. Oh, it redirected to Laye line. That's right. I moved it, and GitHub is smart enough to know that I moved it. Beautiful. I typed in Nashiora, I think, but that's fine. I haven't updated the README in forever, but still basically Clang 18 and CMake for testing. I updated that part, the testing part. I think all of this still makes sense if you're trying to build it. Just build knob, run knob. There's some additional configuration in knob if you give a shit. Just go to knob.c, and it's as easy as reading this chain of if statements. Knob builds but does not do anything. It's also the default, I believe. Yeah, if I don't specify anything, it's still build all. Build Laye builds the driver. Run does a build of the driver along with whatever arguments you pass to it. So that's what I'm doing here, is I'm saying knob run, and it's passing all of these to the compiler driver. The other test functions you shouldn't need nearly as much, but ask me if you actually do end up building it with tests. So that's all I'm doing here. Knob run. There's my build and my run and my execute and shit. Cool. So now we need to figure out. I thought we would have made some progress on this before. I mean, maybe we did. Maybe this is correct because I haven't actually done indexing. I just don't know. Okay, well, let's go find out. Now that we're pushed, let's go find member here. So here we're saying cannot index type this. So first off, why are we printing a pointer? If it's for struct type purposes, okay, so it is just the name plus mute. If it's a type, did I skip nameref? Or is it at the bottom? Nameref. If nameref reference type is not equal to null, it's going to show up here. So it is printing a nameref. It has not resolved past the nameref, which is, I think, good. Because I don't think we ever want to print this. And if we do, we can just flag it separately. So we expect for this to resolve to the struct type. So if I go into Sema analyze the node. This value type is the member's value type. When we analyze this, its type should be resolved already. So what might be happening is I don't think this is resolving it. If we go up to a declaration, decal binding, here, analyze type, declared type. So if I set a breakpoint here, and we make sure that our launch.json is doing ast of struct.laye, which it is, then we should hit this when we hit mute vec2i. So declared type has a source node, which it should have but does not. The actual node is nameref. So that sucks. Let's kill it. Start at this breakpoint, launch. So again, our declared type is a nameref. The nameref in question goes to, there's no declared name because it's a nameref. So anonymous union nameref, this should say vec2i. Wherever the hell nameref is in this list, nameref. Nameref, kind scope pieces, the first piece doesn't have a string with it, I guess. Kind, location, leading, trailing, it's a token. So it should have a string value, vec2i, right? So that's our thing here. We need to step into, why is this over here? I want it over here. Into here. Analyze node, type node. Step over. So nameref, type. Type's kind is type nameref. So let's go into, that's why. Type needs to be type nameref. So then if we run this, we should get a different type. Cool. Semi-analyze node, value node semi-state, semi-okay, or semi-errored, failed. Well, that's new. Unbreakpoint, continue. Okay, because we didn't sema the underlying type, right? Analyze type does things, but if we haven't sema'd the underlying type, then we should sema-analyze. Just reanalyze the bitch because we've changed its underlying node. Right? Run it again. I can't run it again until I've recompiled it. Does this change anything? Okay. On node kind type struct, we have hit an assertion, which I now expect that should be in somewhere. Okay. Because we aren't analyzing a struct type, I don't think. Obviously, that's what we're hitting here. So let's get out of debug view. We need to go back down to where we're analyzing types. Here we're doing a type array. So let's case Laye node type struct. Break. Then we should hit here, which will be fine. That should just say assert false, bonk, 1406. For some reason, we've never analyzed a struct type, which sucks. So let me come up to my top level declarations. When we say build struct type, that's in use by semi-resolve top level type. So once we've done this, here's where we need to say sema-analyze type. For sema and node declared type. Okay. And once it's been analyzed, it should continue to the same thing. Cool. So then this will analyze it ahead of time, and we're going to hit this case. So what we want to do is something very similar to what we've done with the array here, except for types instead of values. We want for int64t equals 0 count array count node type struct fields I plus and 0 I plus plus. Then we grab all the fields, and a field is a node, I believe. Type struct field. No, yeah, it's just type Laye struct type field. Laye struct type field f, we'll call it, is this sub I. Inside a type field that has our type name and evaluated initial value. So I really don't want to copy this, basically. I want to say analyze type, comma, and a reference to this. Like that. And for now, that's all I have to do. Incompatible pointer types. What am I missing? Struct Laye type pointer. Incompatible pointer type passing. Oh, because I didn't do dot type. That's what I wanted. Some of the type. Cool. So then node type node kind not equal to type unknown. So I haven't retyped it. It should have a type. Hold on. Because it should be type. That should have been done up here. Where's our top level shit? Top level types. Constructing a struct type here has type. So am I reading this wrong? Analyze node, node type, node kind. Should not be unknown. But when I'm constructing the type, node declared type, node kind. That's fine, but I'm doing the declared type. That would be declared type node type. Should be, hold on, let me come back down here. Assert node type kind. Order independent declarations, yes. Node type node kind is not equal to type unknown. It should equal type struct. And it does not. It's because it should be type. It shouldn't be Laye C, sure. It should be type. Laye node type. That's what I mean. Okay, so node type node kind. Node type node kind here is node type. Node type exists somewhere in here. Node type. Type is definitely non-zero. So invalid and unknown. Type unknown happens elsewhere. Right there. They're not the same thing. So what the fuck? It's got to be somewhere else. Kind equals type unknown for a node member. Oh, because we got past member initialization. Or not initial, but sema for member access. Oh, I'm just looking at the wrong spot. This is why you run things through a debugger. Member colon. So in this case, we're hitting node type struct and doing nothing. If I remove this, it's going to say cannot index, and we'll get past false and unreachable for type print to string. We didn't hit type struct. Let's go print a struct so we can prove that this is working otherwise. So debug node type struct, we'll put at the end here. Case Laye node type struct. Break. In order to print a struct type, we're going to do something very similar to the name ref type. So I'm just going to copy its formatting. We want, where the fuck is the name? This part. Color name. That's really all I have to say is color name. So color space, so then string expand, type node, type struct. Should have a name associated with it, right there, like that. And the name is a string. Beautiful. Run. So cannot index vec2 imute. And it's got the type qualifier with it, which is beautiful. That's exactly what we want. We want a type qualifier. So then we can reintroduce type struct, and worst case scenario, we set everything to errored again. I really need to start using debuggers. I rely on printing a lot, and that does cost me. I print things sometimes, but a lot of things can be fixed by just hitting the debug button. That's what a lot of my asserts are for. They may as well be printfs that just printf when they detect the error instead of all the time, right? So that's what got me started on the debugger at this point, was all the way down here. We had the assert that said assert node type kind is not equal to unknown, right? This was basically my printf that happened when the runtime failed. And from there, I can use this information in the debugger because it's a printf that also hits a breakpoint. Right, when this goes off, I just hit debug, and I can immediately inspect the state of the thing that caused the assertion. So asserts for me have become my hybrid printf debugging. Print it on runtime, and then debug time it stops. It's great. If you're using a C-like language, I highly recommend throwing asserts places where the type system fails you, or asserts where you know you need some certain logic to happen beforehand. You know, just use asserts for what asserts are for, and they will help you start using the debugger more. They are fantastic. If you weren't here to see last time, yeah, definitely use assert. Build your own assert if you can. I didn't do that for Laye, and I regret it. Last stream, a couple hours ago, though, I showed people I have 1,500 asserts in here, only a handful of which are not in my source code. I assert every fucking thing. And these are all of my printfs that get compiled out of the program when debugging is not enabled. It's beautiful. Yeah, this is like the N3 write. I haven't kept count. Laye has existed in like 10 or 20 different forms. I'm on a rewrite for lots of different reasons. This one is promising. I'm not planning to ditch it. Okay, anyway, we left off with left-hand side of assignment is not mutable. Cool. So we've made this an error, but it's not printing that it's an error. So the only thing that's missing now is left-hand side of an assignment is not mutable, because we are not setting the type to something that is mutable. First of all, if it's a poison type, it should probably not report the immutability of something. But that is for a different day, because technically this poison type shouldn't exist. That's fine. Well, no, because we're still going to get that error even if this is a thing. So let's include write error for sema context node location format in progress, just so we can see that there's an error visually there when it's a poison type. And let's go fix this left hand side of assignment is not mutable. If this should be not poison, right? So if I do that. Error in progress. Cool. So we've got the 3 errors for it being in progress, and the poison type is now correctly telling us that the left-hand side must be mutable. So that was another bug to fix. That's good. So now we need to do struct access. So the struct type itself, I'll probably do a rewrite later again because I'm still not happy with how it turned out. Yeah, so long as you haven't sunk like endless hours into it and don't feel bad about it, rewrite the hell out of it. Even if you have sunk endless hours into it, if you're not happy with it, consider a rewrite. Maybe consider a refactor if you can before a rewrite, but I can't really tell you not to rewrite things with how often I rewrite things. It's fun to rewrite things with all your future knowledge, your brand new knowledge you got from the other rewrite, but eventually you gotta stop somewhere. For me, this is the point where I'm stopping. This will be the Laye compiler until I decide to bootstrap it. Which I hope to do sometime this year, but we'll see. Okay. Laye node struct type node would be value type node period. I just want a better name for it. Struct type node is our value type node. So then we want to do a lookup of what we are indexing. What is our member name? So we have our value type. Let's also get a string view for the member name, and that's going to be node member field name. which should be a string view, is a token. So string value, which should be a string view. Yep. I'll go ahead and grab member location. I don't have to look it up later. Like that. And then I may as well move these down here. This is a, let's see, location and node here. Member field location, node, member field name, string value is a string, not a string view. That's right. I don't remember why they're owning strings. Oh, because string building from the string type itself. That's right. Eventually writing my own backend, not right now. We're using LLVM primarily for now. And we're just taking our internal IR and printing it to LLVM's format instead for the whole thing. Only a few hundred lines of code and we've got LLVM. Eventually, I want to have a machine code backend for at least x86 and maybe some other things, but at least x86 on Linux and Windows. And a WASM. I want a WebAssembly backend. Use Smart Booga. Interesting. Those two eventually. Maybe some more. Maybe we have a C backend just to get it for free on other platforms, but LLVM does that for us right now and is more pedantic. So. All right, struct type node is here. So then we want to do a lookup. So on struct type node, type struct fields, yep. So for int64 I equals 0, count is our count of this I++, or I is less than count. IC is less than count. I++. We're going to grab that field. Where is my syntax highlighting? Cool. This is still wrong because I need this to be a string view. So string as view is a function. Okay. So then struct type field f is this. Do a lookup. Love lookups. Lookups are fun. Cool. If string view equals, God, fat fingers. String view equals member name f dot name, which should be a string. It's a string. It should be a string view. I feel like member name, or the field's name here, should be a string view, not a string. So should the variant and type variant. Those should all be string views. String view. So that'll error somewhere in the parser probably, and I'll fix that later. String view equals member name, f name. Then we have an index. What to do with that, I don't know. Let's say int field index. I'll call it member index. That's fine. Member index. Do the yield. -1 is an error trick. So if member index is equal to I now, then we want to say I is less than count, but also member index is not -1. Then if member index is equal to -1, we break, saying we didn't find anything. This is where this error is going to go. Using string views for everything except managed names. Exactly. Or mangled names. Yes, because I'll have to generate a mangled name, so probably same thing. I use strings to build the internal representation of strings from the parser, from the lexer. I use strings to generate a lot of text, to be the initial storage of text, like for files. And then I view it later. Only a handful of things actually own those strings. Everything else is a view, yes. So, no such member mod.stars. I think I do dot for all of my errors. String expand, member name. Then I'm going to keep my in progress down here. Just so I can like, oh, hello, that's not my terminal. My terminal is this. Okay, so now we have field no declared name needs to be done in sema. Oh, that is a sema error. Okay, that's all the way the fuck up here. Declared name from a string. From a fucking, why is the declared name not a string view as well? What the heck? This should also be a string view. That's going to change so many things. Okay, so declared name in both cases, that's fixed. So then IRGen might have errors. Let's see. Here? Foreign name. The foreign name here should also be a string view. What the fuck am I doing? Okay, then I am turning it to a view before it gets created into an actual function, but there we go. Okay, so then the parser here has to deal with a whole bunch of things. This error here, the foreign name here is meta attribute foreign name. This needs to be a string view. Okay. Foreign name is foreign name value. Foreign name value comes from the token's string value. So in this case, the token string value should be interned, really. This should be string view as well, which is going to break even more things. That should be a string view. So then just that string as view, because once we get into the token, it should be interned within the compiler. We don't need the string as view here. But scope name doesn't need to be a string either. What the heck? So many things wrong. Scope name, compound scope name, doing a string view. I'm not even sure I want this scope name thing. I put it in here thinking I'd be combining things like this, but really, one, this is going to get moved out here, and two, that means that breakouter needs to, I mean, I might still do this as a shortcut, it's just not going to happen in the parser. So, I mean, name token string value. So if parser consume name token string, so what is this even in? Because the parser should not handle this. Parse declaration continue. What? Why are we doing this here? Function body compound scope name. Oh, because it's becoming the name of the function. So we don't have to. First of all, I don't think that matters. I'm going to remove it, but weird. Lit string value for a lit string expression also needs to be a view. Not gonna lie. Okay. Break target needs to be a string view. God, wow. I'm not parsing a lot of this yet, so it's the data structure's fine. Token string view is context intern string view, which should return to me a string view. Why doesn't it return a string view? What the fuck? All right, Laye c.h in turn. First of all, second of all, we need to now return scount plus one. Blah, blah, blah. Are scope names used to break out of scopes, like break? Yes. I haven't decided 100% on the syntax, but I think it's just going to be label before entire statement, and then Sema will keep track of that. Maybe the parser shortcuts it. I don't know. Okay, so if scount plus one is greater than this, then allocated string. We aren't even interning yet. Oh god. So what is this doing? Context max intern string size. What? Oh. Oh, this is bypassing the arena allocation. If it can't fit within the arena, then it just allocates it outright. But it should still return a string view. So when we have an allocated string, it's string as view, allocated string. Then the same thing here, string as view, allocated string. We don't ever want to leak the owned memory of a fucking arena. It's not reallocatable. And then we don't have a lookup for interning strings yet, but that's fine. So then layac.h, okay, parser, go back up. So now we've got trivia text. Trivia text needs to be a string view. I don't think we're using that shit anymore. Parser looks to be fine. Sema now has more things to fix because we don't need to string as view this anymore. It's just the string value. This is just a string value. This struct name should be a string view. Why are these owning strings? I am absolutely baffled. String view equals svconst. String as view of string of view doesn't even make sense anymore. Okay. Then down here, string as view. Boom. Now. What else is there? A fuck ton of errors. Whoa, okay. IRC. Didn't have an open, didn't know it was going to be an error. Module name is a string. Fucking why? Okay. Then already returning its own name. That's fine. Block name. I swear. What was I thinking? Okay. Don't need to return. Like, I knew I wanted to return string views from the functions. They should not be owning anything. Function name? Are you kidding me? I'm not surprised anymore. I'm just, why? Intern string view. Then don't need to return this. All right, what's next, ye old compiler god? String equals. Interesting. Passing string view to both, so that's data. Follow through data.c. This should be string view equals on both. This name. This are the same. Then string value for the constant. I can understand why that might be, but it really shouldn't be. That's going to change things. What now? String view to shared. String view equals. string view to iOrigin. Way the hell down here. Module create global string pointer. Should take in a string view, which then needs to match the declaration. So come back to this in a second, but this needs to match the declaration. Search capacity. We don't need a capacity here. Create global string pointer. String value capacity greater than or equal to the module count, or to the string value count. What the fuck are we even doing there? There's the array type. Cert. Okay, this is just checking that it's null terminated, basically. So we can't guarantee that it's null terminated without having an actual string. Array constant, but that's fine. So I should probably be copying this anyway. Not that I want to, but I should be. So array type, string value count +1. Yes. Then the array constant is Laye array constant, location array type, value data, value count +1. True. So what I should probably be doing is making an array constant own its memory. In which case, I need to allocate my own data. What we can see here is Laye value destroy, which is not in Laye H. It should be in IR. I stole it from LCC, which stole it from LLVM, but yes. I am generating LLVM as my primary backend, so it made sense to call it the same thing. We're just gonna stick a fuck ton of to-dos there to remind me where we're at. Yeah, I stole it from you and you stole it. Right, so we need to own our data. We need Laye value destroy to ensure that it can destroy that data. So in case Laye array constant. Let's see. We want to just straight up free, probably. We could do an array free. But we might just want to straight up free some memory. So if I say free value array constant, is string literal data linked? Yes. Okay. Array.data, easy. Then somewhere down here, we had our list of to-dos. So car data equals alloc, just a straight up alloc. I could pool allocate this as well, and I may, if I add it to a pool, does my module have an arena rather? I do have an arena. I should probably just use the arena then. And instead of do this, we just use the arena. Arena push this, and that'll be string value count +1. That simplifies my life. Mem copy into data from string value data. N is string value count. Then we just data count +1. Then it should still be freed. It is now guaranteed to be null terminated. As my arena push zeros the memory, or it should zero the memory. Mem set 0, yep. Okay, so now we have an owned null terminated array constant. So that should work. That should be fine. Now what? No such member X, Y, or X. Okay. Interesting. Interesting. So back in Sema, we're getting here. What are our options? We're not hitting anything in there. I probably didn't construct this type correctly if we're not getting anywhere. Fields is, it has a value. The first one has an a type of name. The name is X. F.name is X. Okay, what's count? Count hasn't been initialized yet, so step over. What the heck? Oh, because I inverted this condition. Okay, that's what I expected. Okay. So now it has found X and Y both times. What I should probably do is store the member index that we're using as a lookup here in the node itself. Right. And we should also probably, as like a first step, oh yeah, a set L value to the thing. Okay. So then here we know it is a thing. So I think we want to say node dot member dot member index, let's say, because it's almost always going to be indexed. Will be member index node member type, node just straight up type rather, will be a qualified type. That will be the thing we look up. So we need to create a field member index. Good enough for now. So that sets the member index. The type will be the member type, which I should look up and keep. Diet type member, which will just be 0. So then member type will be F type. Member type. Why is this not happy? Member index is an int 64 in both. Node member index. Oh, because I put it in the wrong fucking place. Okay. There's our type checked program. So let's get our struct example back out and compare. So we have a declaration, boom, declares vec2i mute v. Easy. And as we can see here, the name ref here still has the address that it's pointing to. But this has been resolved to a struct type, which is no longer a name ref, so it's just printing the name of the struct type with no declaration. So then the assignment here is v.x equals 34. Member initialization, we want to get the int mute int here, you can switch those around in Laye, it's fine, x out of v. This means it's an L value, so this is also an L value. So this is an L value to v.x. The type is vec2i mute. The name is v, referencing this binding declaration. This binding declaration 398 is this one, 398. So v points to decal binding, has type vec2i mute. X is an L value to int mute. Since it is mutable, we can assign to it. The evaluated constant here is 34 of type int mute because it was implicit casted to the value of x. Y is exactly the same thing, but with 35. And then when we return, we are casting L value to R value, which will load the value for both v.x and v.y, and we are summing them with the plus. So, other than implementing member, I think we're good to do IR gen. If I do IR here, this should tell me that we haven't implemented member, and probably struct. We haven't done struct or member. Let's see which one it hits first. Type struct. Okay, so we need to go handle type struct in IR gen. But before then, let's git add. I'll do everything at this point. So we can say Laye, I'll do sema. Perform sema on member access. And just to prove that things work, if I remove the mutable modifier from y, it will tell us left-hand side must be mutable. It's not, because y on line 12 here is not mutable anymore. And also, we can put the mute on the other side. We're doing C-isms with east and west mute. Then we're back on type struct. Cool. I'll leave it on the left. For consistency. These. Okay. So now in fucking IR gen, you want to hit line 104. I love seed syntax. I am stealing everything from it. It's kind of obnoxious, but also it's fine. So to generate a struct type, we want to cache struct types. We really do. Push the git commit. I wasn't going to do it till IRGen worked, but sure, if you want to go take a look at that. Okay, so with array types, we don't have anything to cache, that's fine. With struct types, we can... So I said we were going to cache it. We may not technically need to cache it. I don't think most of our backends care. LLVM cares in that if I want to give it a name, it should probably be the same type, I think. I don't remember if two differently named struct types that are otherwise identical are the same type. So if I never give it a type name, it's fine. But if I want a readable LLVM output, it should have a name. So we're going to want to cache these and refer to the same type every time. So let's create a cache somewhere. Convert type doesn't have access to anything that would cache it, though. Oh, it does. It has the context because it comes out of the type. So within Laye context, which will be in Laye IR, all the way at the top somewhere. No, that's shared. That should be where the context is just declared fucking top level, right? Yeah, okay. So in the context, we should probably have a list of struct types by name. And if we do, we need some way to key off of it. So if I go in here and say dynamic array of Laye struct type, as a wrapper here, and really, I might just go the fucking anonymous class route. I never intentionally want to store this anywhere. It's just for key value purposes. This would be Laye node declaration, Laye type, all struct types. And then we would write a routine to do caching here, or just look it up ourselves in convert type. So for now, we'll do it ourselves. Laye node type struct. We can then say for int 64ti equals 0 count equals r count of context pointer all struct types I is less than count I plus plus if context all struct types. So problem, the thing that we want to key off of here is a Laye type. So it should be the node itself, the type of the thing itself. So I'm just going to call it node instead, because it's not technically the declaration. If all struct types sub I dot node is equal to type dot node, return all struct types sub I dot type. And that is that. Otherwise, we want to adhere to that contract and push. So, I actually don't know how to push that. If I were to, yeah, because I have no way of allocating that type now. If I did like an R set count, that just sounds like a hack. So I might have to give this an actual type. Oh, I can give it an actual type because I can call it struct hash struct type. Duh, because we have name spacing, right? I'm pretty sure I can do that. That looks like the highlighter doesn't like it, and I don't like it personally, but I can change it later. I don't think that works, though. I think if you give it a name, it has to be part of a declaration or something. We're going to find out. I'm going to use the same name even if I take it out. So, struct cached struct type p will be this. Dot node is type node. Dot type is going to be struct type, which we're going to construct, and then r push context struct types. Right. So then we just need to make a struct type. Laye type struct type. Laye type create. Laye type. So I'm in IRGen. Converting. Oh, because we're converting it to. No, that's right. Convert type. Oh, because it's not create type. It's Laye struct. I don't have a constructor for struct type. So we've called it Laye void type, Laye int type. So convert type, whatever. So we want Laye struct type. And to do that, we want it to be constructed in context, I believe. So then it needs a name, string view name. So type node type struct name, first of all. Then it needs a list of fields. So that'll just be fields. We'll have to get the fields from somewhere. Then fields will be probably a regular ass dynamic array, or we could give it a count because we want it to be a static thing that doesn't change, so we should probably give it a count. Fields and field count. So int 64t field count equals node type node type struct fields our count of that. Then we want an array of fields, which will be types. So Laye type pointer fields is going to be array or arena push context arena type arena. That's fine. And then we want to do size of fields times field count. Is it not happy with that? It should probably be a pointer to pointer, honestly, but that would do it. Incomplete type is not allowed. Now it's not incomplete, and it's correct. Okay. So then in laye.h, that is the open menu. We are already there. We want to find Laye void type. So we've got function type here. Function type is using a dynamic array. So maybe I just use a dynamic array and call it, instead of doing this stuff, dynamic array. It's fine. We've already got allocators and deallocators for it. So make it null, and then array set count fields field count. And field count, I guess I could keep field count flying around, right? There's no problem with that. Okay. So then struct type. Laye type, Laye struct type. Laye context, context. String view name. Laye dynamic array. Laye type of field types. And I think that's all we care about. We will eventually care about where we put padding because reasons. We may eventually care about padding. Do we care about padding at the IR level? I don't think so. I don't think the IR gives a shit about padding. I think each of the backends gives a shit about padding. But if we do it at the IR level, and we do padding at the IR level, then every backend gets the same layout guaranteed, which I think is correct. So if we do padding, then our member lookup has to care about the addition of padding as well. Right. Charade, IR padding, yes, no? Am I overthinking that? For now, we're not overthinking it because we're not doing it, but... Okay, struct type, cool. Currently, not inserting any padding into struct types. Should it be done by or before IR gen? Should my IR type have padding in it? I remember seeing you do padding in source, but I don't remember if you did it here, and I don't have it open at the moment. Because if the IR does padding, yes. Yeah, so my stemma, though, we're just storing the index of the field. So what I might need to do then is when I generate a type, I just need to get from member index to padding offset afterwards. Yeah, at the moment, no align as. And if we did, we would do it beforehand. Right. So just transforming this member index, translating this member index that we get in SEMA into the actual field index post padding in IRGen. So maybe what that means, I can use that as the, I hate this fucking, okay, so like, if anybody know how to fix this in YouTube, because this is annoying. This fucking hard. Use it as the index for the gap, yes. I can read it now because I opened it up and I can read behind this thing. But why the fuck is this here? And why can't I read messages? This stupid button. Hate stupid button. Okay, so I might then want to do padding at the SEMA level so that this never has to be transformed ever. Because yeah, then the member index of the GEP makes sense because it'll align. I won't have to do any transformation. So I think that's what we'll do is when we do analysis of types, before we even get to IR, we do local. This needs to handle heading. What other option? Type is a get and LVM is irrelevant. Yes. This is true. But I don't have a byte offset yet either. I'd still have to calculate that somewhere, which includes calculating padding. So even if the member index became a byte offset, I would still have to do SEMA byte offset calculation. Yeah, I wouldn't mind doing that here, and I might also if I go back up to my member thing, I don't even know where I put it. Member colon here. So we've got the member index, but we should probably convert that to an offset. convert member index to offset eventually when adding, please. Interesting. Okay. So everything is just going to be a gep I8 pointer. Okay. Covered up by the thing, so everything is going to be a gep I8 slash pointer add eventually. Okay. Yeah, then I'll basically switch to just doing a pointer add and generate whatever's correct. So 2 things to do. Convert this to an offset. Maybe we just do it right now then, so I don't have to do both. That probably makes sense. Then I can change my IR while I'm at it as well, because the IR is doing gep by member index, I think. Gep. The element type of a gep, for example, does exist. Probably should not. Index count, the number of indices that we're doing. So pointer add. Yeah, let's just fucking include that in our ability to do IR stuff, I guess. So somewhere way the hell up here, we've got IR types. So get element pointer and get member pointer. Really just become pointer add. That's what we're looking at. And pointer add just is regular addition anyway. We don't need a... Well, yeah, in LLVM I can do a gep I8, but this is my IR, so I can do it whatever the hell I want. So I can translate pointer add to get element pointer. But like, could I not just make this an add instruction? What's the significance, at least on LLVM side, of having a separate pointer add instruction versus just addition? Does it just support a plus b plus c plus d, where regular add only does a plus b? Okay. So basically everywhere that I've got gep, we want not gep. So what we probably want instead is just bias u value. Yes, I don't think my IR is going to care, at least in the long run. Eventually, maybe I will. So I think we'll just keep it simple and not give a shit about any of the fancy pointer stuff and just say like Laye instruction pointer add. Yeah. So if I had just a function to get the address from a pointer add. And so again, does the pointer add instruction still take multiple offsets, or at this point is it folded into a single offset? I haven't decided if I want to do one or the other, just one. Okay, that makes the most sense, and then you just fold it down. So get offset from a pointer add. So we have 2 values here, and that's all we care about. Okay. So then we have a build gep and a build gep many. We really don't want to build gep many anymore. And build gep going to become build pointer add. and then it doesn't need an element type, it just needs the index value and the address, which will be offset value instead. So then build gep is right here, will be replaced with build pointer add. Build pointer add okay, so then this IR pointer add, boom, boom. So for my purposes, I could still just turn it into an add instruction, honestly. But then I'd have to technically have both types be the same type. And so I'd technically have to cast both to pointer. So pointer add is still probably better from a typed perspective. That's fine. So pointer add address, pointer add. So we have address here, and then we have operand. So I'll probably just remove the gep part. There's a gep here, which we don't need anymore. We can just use pointer add operand for offset value, like that. Okay, so then up here, get instruction pointer, whatever the fuck. Don't need that anymore because we have these new functions. We have a struct type we have to do. We have right above the builder API is the instruction API. So that'll go here. Assert pointer add, not equal to null. Assert pointer add kind is equal to IR pointer add. Return pointer address, and we may as well throw a final assert that address kind legacy is pointer of address type to assume good. Let me know if YouTube actually lets me send the link. You can take a look here if you want an example of why the optimizer might have trouble dealing with gaps, because there are many different ways. I don't see a link. So you can send that in Discord though. Discord, either in general or in the live text. I am in the voice channel. Where is the text alive? The text is alive here. Hey, look, there it is. I'll look at that later then. Give you a gold star. Because that might be interesting to read up on. Okay, so then here, we want to get the offset, and we can assert that the offset is int, and that's the operand. Cool. So then down here we have something. This is Laye IR pointer add. I don't know why I didn't X macro this, but you know, whatever. Then IR get element pointer does not exist, and there's nothing additional to free. So then down here, when we're printing it, pointer add is going to turn into etr add type print to string. It'll always be a pointer, so that I don't need this. Value print to string. False, we don't need the type. Instruction address is fine. Then we print a comma, print the type of the operand, like that, and that's pointer add. Okay. So then I'll have to change the IR generator soon, because there's a handful of things I think that use that. There might not be, I guess. They might not have made it to IR gen yet. I feel like they should have, so let's see. Get element, build gep. We do have a build gep here. So build gep is going to return instead Laye build pointer add, which again I did forward declare, right? It exists here. Did my forward declaration? Yes, it did. So here, build pointer add. We don't want the element type. There. So the value here, where are we declaring value? This one, generate node, the builder, whatever. Assert value is not equal to null. It should also be assert Laye type use pointer, Laye instruction get type, Laye value get type value. Right? And the indices here should have Laye type as pointer. Okay, so we already did that. That's fine. Value is not null. Okay. Okay, and the underlying type of the pointer comes from the syntax tree, so that's fine. If it's an array, else unsupported. That's fine. So then this becomes pointer add. That's fine because calc index value is already doing this work for us. Cool. We could read it on stream. Let me copy. That's the text of the thing. That's not what I wanted. Where's the copy link? There it is. Yeah, that's a lot of things that are the same. Reading in my head because I don't want to read out loud. Sorry. Skim, skim, skim. Hey, that's exactly the syntax I thought they'd choose. Let's go. Okay, so scaled variable offset. Interesting. Pointer add inbounds pointer. Offset. Sure, yep. Yep, so still pointer add plus whatever. And we're not allowing pointer arithmetic at the moment. Eventually we will. So we'll have to do sequences of pointer adds, but that's fine. So the result of pointer add is another pointer, but so is get element pointer. So this should be semantically identical, which is great. Okay, cool. So there's a lot of things going on. That sounds cool. We're going to do the same thing. So build gep. I think that's the only place we use geps at the moment was array access. So pointer add instead is good. Okay, so we left off generating a struct type, right? Struct type needs a thing. So that's here. Make this bigger so I can see it. So we'll do something similar to this, probably, except for that we have this thing here. So we can assert that. Okay, Laye type struct. Okay, and this is struct members, I guess is what we've called it. Yield types like that. And struct name, which is a string and should be a string view, is name. Or index, that's right. Interesting. Named would be true then. If I'm going to set name to true at all times until we do a check. Okay, so then this type that, and that would do it. So for now, we're going to assume that name dot count is not 0. And if it is 0, then we'll do unnamed structs. So we'll get there when we get there. Okay, so then. We still compile. What's next? We not git push. Lots of errors because gep. Yep, so I think the LLVM backend is primarily what this is. Yeah, that's all LLVM. Not open. LLVM. So here, for pointer, we want to say get element pointer for now. We want to print type that it's always going to be a pointer. Well, no, it's not. We need an I8. It's always going to be an I8. Get element pointer, replace print type with I8. Replace this comma with a comma. Then we print the value of what we're loading from with type information, which includes the pointer. Get instruction address, then print a comma, and then print the value, which is ISE instruction operand. Like that. So then that should be our pointer add. Okay, non-void function, IRGen 187. That's here because we haven't returned struct type. Okay, so then we've got printing type struct, I assume. Type size. Oh, no, size of struct. Okay. That's where we're going to want to probably already pre-calculate padding. So we'll implement size of a struct without considering padding, just assuming that it's already pre-padded, because Sema very soon will do that for us. And that'll be fine. So size is in IR 818, IRC 818, case YSC type struct. We then want to say int size starts at 0, and then we just add for the size of everything within it. So note generation of this struct should include padding. So we don't consider it here. Or int 64t I equals 0, I is less than count I plus plus. We need to get a count. Count equals array count of type struct members. Okay. Boom, easy. Then size plus equals size in bits. I see type size in bits. Type struct members I. Easy. Probably going to complain about alignment. We didn't return size. Okay, unknown address. Yeah, for some reason ASAN doesn't work in Viz in whatever this terminal is, so that sucks. But it's also running the wrong thing. So It's not hitting that because we need launch to be running IR now. There it is. Okay. So type. Whoa. Type is Okay, so that's going to come from type size in bits somewhere. This type is a type struct. The struct members has stuff in it, but there's our which doesn't exist. So are we not pushing the members correctly? Make this tinier. Get rid of this. So in IRGen, struct type, we're not setting any of the members yet. We forgot to do that. So set count expands two things. Yeah, okay. So then we want to say for int 64ti equals 0, I is less than field count I plus plus. Field sub I. I feel like this rset count didn't work either, but we'll see. Fields sub I, because it would have been zeros, not base. So field sub I equals convert type for node type node type struct fields sub I dot type, like that. Then I expect that to also No, it worked. Okay. For node kind of member. Interesting. Okay, so then that's going to be way the hell down, not actually that far down. So member is going to come after index, I think. Base member. So here we have something to return. I should probably grab some water before I am running out. Okay, so to do a member initialization, we need to first go finish Senna. So this should assert false, so we don't get farther than that. We know where it is. Okay. We wanted to go into Senna first to do struct alignment. So what I should do is here. If we hit it, then we're at the right alignment. Else, so instead of member index, this should probably be member offset. Right, and then we would need to know if the member offset is greater than or equal to the size of the type, I think. So I think here we just say break. Here we say member offset is 0. But then if we don't find it, yeah, then we'll get to the end. That's what that means. So then if member offset is greater than or equal to size in bytes, bytes. Do we want to do it in bits or bytes? I think bytes, because we're doing I8s. For struct type node, so value type. Then we break again. So then member offset, we select the type here, that's fine. The offset, member offset plus equals struct Laye type size in bytes. Easy as. So then instead of member index, it's member offset. Yes, and then we'll just do this manually to make sure it's correct. So then there's member offset and type. Then And then Laye type size and whatever needs to support struct. And it's going to be a very similar thing to Laye C ir.c with fucking, oh, we're already here, okay. Struct type here, just copy this yoink. It's expecting an int, so array count here of type node type struct fields I is less than whatever I plus plus size plus equals the size in bits of this dot type. And the variant will have to have the same thing going on. We don't have variants just yet. So assert our count type node struct variants is 0. If there are variants, we are not prepared yet. But variants will turn into an array in the IR, so it'll be fine. Fine, which makes offsets even more useful, actually. That's great. So. That's that for the size of a struct. The align of a struct will be the largest align of its members, right? So if we come over and do align in bytes, we have a line in bits. I think we just have a line in bytes. So case Laye node align struct int align equals 0. I guess the alignment by default should be 1. I probably will cache. It does. It does sound expensive. I probably will cache. Not at moment because lazy. I'll add a field to cache it in just a second. And if it's 0, we'll recompute it or something. So for int, I'll just copy the same loop up here. So I've got the same thing. Then we can say int f align is going to be align in bytes. Laye align. I do have a line in bits. A line in bits. So then why do I have a line in bytes? Separate. Interesting. I'm actually confused now why I've done this. Laye type align in bytes versus align in bits. Where did align in bits even go? Doesn't exist. That's Laye C type. That's why Laye type align in. So Laye type align in bytes is the only thing I have, but Laye C has bits and bytes. Okay, that's fine. Int line of the field is this same thing, sub I dot type. Sub I dot type. If f align greater than align f align. God, fingers. If there's a variant, don't do that. Okay, so that gives me alignment and stuff. Okay, so then there's our false assert. So back to Sema. That should give us no such member. So let's go back to struct and say vz equals 10. That should still give us no such member z. It does. So that check is valid. So now we need to go to wherever we're doing struct type analysis and alter our struct type here. So, um, inserting padding. I don't think my vector library has any insert capacity. It does not do inserts. It does push pop, and that's it. So I can't insert at index. Either we quickly throw together an insert macro, or I do it by hand over here, or I build a new array and replace it. Building the new array sounds easiest. But, I don't imagine myself doing much inserting anywhere else. So it's probably fine. Okay, that's fine. So. Because we only want to insert immediately where we're at. Now we can just I++, but then count doesn't change. So what I would want to do is keep count dynamic, not initialize it ahead of time. And then say, 1, analyze the type. That's fine. Then we need to know the alignment of the type. So then we have int f align is going to be Laye align bytes of this type, like that. Assert f align not equal to 0. In fact, it should just be straight up greater than 0. Then we need to know our current offset. So int current size, I guess. Current size is 0. So then we also want to know the size of the thing. Size. It's right. So then we want to align the size up to the alignment of the thing, up to our current alignment, which is 1. So then what that means is int padding bytes is the whole thing mod the current alignment? Question mark? Because if we have current size, and then we say modulo the current alignment, and current align, we then want to set up to be if f align is greater than current align, then current is f align. Then current size modulo the current alignment. That is the current alignment minus this is the number of padding bytes we need, question mark. So if we had 4 bytes out of the 8 alignment, that'd be align minus model, the mod align again, yeah. So align minus value, which is size, mod align again. So I was correct, I just need to mod align twice. Cool. Align minus value mod align. Cool. So that's our padding bytes. And only if padding bytes is not equal to 0, greater than 0, do we want to create a new type to go in the middle. Which then requires that we do an insert. So let's say define LCA DA insert v IE as do while 0 something. So let's go ahead and do a after back, which really probably should be before back of insert IE insert, put it above back, because back is wrong, by the way. Don't look at back. At least I'm pretty sure it's wrong. Back should be the value, not the address of the value. Okay, so then insert needs to, you can just have a current offset and keep adding the padding and the type size to it. Yes, that's what I'm doing. Or you can just have a current offset and keep the padding and the type size. And I can't see the end of it, so to it, yes. That's what we're going to be doing. Current size is the current offset, but it's the size of the whole struct, so that we can do that. And the current alignment is the alignment. Yeah, and this is what we can use to cache the size of the struct, so we don't actually have to do the calculation necessarily if it's here. And then the alignment set, we can cache both of these very easily. So. Right, anyway, so then we want to create a new field that is padding. So in order to insert something, we need it to be of the same type, which is going to be this field type. This field type is Laye struct type field, yes. Laye struct type field, padding field is a thing. It needs a name which shall just be 0. It needs a type, and if it's just going to be 0, all I have to do is give it a type. So dot type equals our type. It'll be padding type. Laye type padding type equals dot node equals node create, which is going to be padding type node or something. Laye node create type array probably. Node module type array. The location of this padding type thing, whatever, can be in node location, and the type would be lty of context. We don't have a context here. Module context stemma context Laye types dot type, like that, right? So then we can insert padding type node null, then padding type node, and really this whole thing I just did, that's this macro lty, like that. Okay, so then padding type node array, our container, dot element type is going to be lty of stemma context Laye types I8, right? Then padding type node type container element type dot length values are push. And then this constant, now I need to be able to generate an evaluated constant, which I guess I can do by, right, that's what this is. The node pointer, and it has to be evaluatable. So Laye node constant value would be node create, node module, node type int, or not type int, node literal int, node location, lty stemma context types, just straight up int. Boom, easy. Then constant assert, constant value, not equal to null, constant value, int literal, int value equals padding bytes, analyze node constant value constant value type would be an int, right? And then assert that that's true, really. First off, why is it still erroring? Just because it's not, yeah, it hasn't caught up yet, okay? Then we want to push constant value here, which should be evaluatable, but it also probably should just be evaluated. Evaluate. Like, how do I analyze node here? It should just become evaluated. Assert constant value kind is equal to node eval. It should just have happened by analyzing a literal like that, especially converting it to a type. I don't know that it will. Converter error, because it's the expected type is not equal to null. Converter error will go through semi-convert. Semi-convert will go through convert impl. Convert impl will go through and say, if they're both pointers, no op. Well, if they're both these should be poison. That's why I was confused. If they're both poison, no op. If they both contain errors, no op. If they're the same type, it's a no op. So it's not going to convert. So if I want to do the conversion, I'm going to have to do the conversion myself. Create constant node from the eval result. So this is how we evaluate. Let's just do the evaluation inline. Wherever the hell we are. Analyze the node, generate a whole ass evaluation result. So the padding type here is this. The constant value is that. This gets, God, I really need to have like just a solid evaluate. So expression evaluates true, should always return true. Then with that, we want to create the constant node. And then constant value equals this. There we go. Okay. I think that works. So now it should be an evaluated constant. Now we can push it to the array type. God damn, I made my life difficult. There's our padding type. Yes. So then we have to insert this padding field, which we have to do by doing array insert. We're going to insert node type struct fields at the index I, the value padding field, and then we're going to I++ to skip over it and get us where we currently are. Right. So then that means current size plus equals padding bytes to get us here. And then current size plus equals the size of the actual thing, which is f size. And then at the very end, we do one more bit of padding. So, fuck, I don't want to have to copy this shit. God damn. So I could create a create padding thing, and that would save my life a little bit. But I don't have anywhere good to put it. So if I said static, I think the most sensible thing to do would be create padding field. ISM create padding field. We're going to grab everything from here. 1, 2, 3, 4. It needs Laye module. It'll need some location. ISC location. And it needs int padding bytes. So everywhere that we see node module, we just say module. Everywhere that we see node location, we just say location. Everywhere that we see node, see that was already a bug. This needs to be evaluating constant value. Okay, then we just want to return padding field. Then here, this becomes Laye sema create padding field sema node module node location padding bytes. And then we just want to forward declare this shit. Remove all of this shit. And there we go. So now we just forward declare it way the hell behind this function. Big ass fucking function. Thought I was closer to the top. There we go. Like that. Then then we can do one final check at the end of this for loop and say once more that we have padding bytes. So let's just do this so we don't have two declarations of it. Going after I++ our push instead. Okay, then that makes sense, right? So then all we have to do is implement insert. So to do an insert, we want to LCA, DA, ensure capacity, but also set count. Set count for V to be LCA, DA, count V plus 1, full stop, right? Then we want to mem copy, mem move probably, but aliasing. So to do the mem move without aliasing, to do it backwards, we're going to just probably want to do it manually. And say, for everything after, move it. So for int64t I equals get the current count plus 1, which is now the current count. I is greater than I minus minus, right? Then V of I equals V of I minus 1, full stop. Right? Then V sub I equals E. Right? And that's an insert. But at this point, count should be minus 1. Still. So for the end of the array, set this one to greater than I. We should also probably assert that I is greater than or equal to 0 in here. Assert I greater than 0, right? So then that's going to get a line. Anybody catch any bugs in that? Set the count to 1 plus. Shift everything to the right one where it's greater than I. Set I to E. Okay, so that's array insert. That expands to a whole shit ton of fuck. But, okay. What happens if I do this? Laye create constant node is not declared. What the heck? Okay. Laye create constant node. Where is that forward declared? It's not. It's way at the bottom. Forward declare that shit. Okay. Then we're back here. What now? Assertion false in generate node. Okay. Probably because we're not generating any padding. So if I said like, I don't know, I8 foo, still gets past it. I have no idea what the size is, so current size 136 plus padding bytes. 136 is a big number. I would expect this to be 12. Well, 8, 16, 24. 24. So what the fuck? Current align. Am I doing bits anywhere? Oh, have good sleep. Current alignment is 8. Current size is 136. Fields should only have 3 values. Am I doing bits anywhere instead of bytes? Size in bytes. Align in bytes. Let's stop at everything. And so f size 8. F align 1. That makes sense. Size doesn't. I8 should be, no, it's 8 bits. So hold on, size in bytes. Align to bits 8 over 8. Glad we're not using this for anything important yet. Size is 1. Size is 8 again. I didn't recompile it. Address sanitizer absolutely dies. Okay, so now we're failing on padding. Size is 1. Align is 1. That's fine. The align stays 1. Padding bytes should be 0. There's nothing left to pad. Current size plus equals whatever. Okay, so now our size is 1. Our alignment is 1. Our padding bytes are still 0. We continue. We now have a size of 8 and an align of 8. Our new alignment is 8. Our padding should be 7. 7 bytes of padding. So we can create the padding field, no problem. Its type is an array type. So now when we try to insert, I imagine this is going to be what throws the bonk. No, it's fine. I++ again. Okay. Interesting. Can I view that in memory? I watch. What am I looking at? Node type struct fields sub 3? No, sub 2, not 3. 2. 0, 1, 2. Type is type int. That's wrong already. What's type? Type of 1 is type array. Oh, so it inserted it before. No, that is correct. Yeah, because it goes before X. So type 1 is the type array. And the type array is going to have a type array, type array, type array, type array, type container. Element type is going to be type int. And the length values is going to have one length value. which is an evaluated constant. The evaluated constant should evaluate to 7. So anonymous union, evaluated constant, result is an int. It's got an int value of 7. Okay. All of that to say that worked. So then where is the bad stuff happening? Segfault here. Node is bebe. So I did something wrong with the insert, almost certainly. I think it's still to do with the array. I can't view all of them, but if I come over here to like 0, 1, 2, 3 would be the one that's wrong. And it's got baby, right? So it definitely failed to copy something over to 3. So. The downside of having this macro system is fuck debugging it. So array insert. DA insert. Interesting that I can't find that. DA insert. So again, I is greater than 0. Perfect. Set count might just be failing. LCA DA reserve if V, which should exist, V should exist. Header count equals N. N. That's fine. Here's my water. So let me run through this again. But let's watch struct fields 0 dot type question mark. That exists, right? Dot type node find. Okay. Copy 1, 2, 3, 4. 1. Oh, it's getting stormy outside. 2. And then 3 should just throw. That doesn't exist. So then continue. Then our alignment is bad. Now that's of type array. But we don't have anything new here. This still doesn't exist. Can I evaluate code here? Probably not. Able to create variable. So I'm never going to know what the fuck array count is from here. Without manually doing array count, which is going to be ruct LCADA header -1 count. I don't think it's got a name count. Isn't that I+1? It's skipping the thing we're inserting. We're inserting at I and skipping the padding. Shouldn't be skipping a field. It has a count of 4. There's just no memory there. No valid memory there. And it looks right. Huh. Not a fan of these. Because why doesn't this have a thing? I don't know. Capacity is 32 anyway, so I don't know why it's baby. Just because it hasn't been written to yet? There's one thing I can do instead of set count here is just push 0. Whatever the value of 0 is. But I don't have the ability to push a 0 value easily, I don't think. But push just evaluates to the same thing. Maybe expand plus this. And maybe expand is the same thing for reserve. I really should just be calling reserve here. Maybe expand up to n. So, I mean, I can try just doing this instead of doing reserve here. And I can relaunch it. Continue. Yeah, it's segv. This memory is bad. This memory doesn't exist. It's BE all the way through. So. The count here. This should set this to 4, which it does. It does not give me any valid data for the next one. That's what asan is doing. I'm pretty sure it's an asan message. Well, it's segfaulting here. So yes, it's a segfault. If I kill it and run it from here, this is what I get. I don't get anything. Because I am stupid and I forgot to recompile. Continue. Step over. If I rerun this, does it work? Continue. Count is 3. What the hell? It should be 4. Stop. We're going to hit padding bytes every time. Or we'll hit this. Run. DDB launch. We hit the padding byte. 7. So again, count is 3. Step over, step over. It set it to array, but now it didn't set the count any higher. That makes sense. Because, go back into DS. We did the maybe expand, but we need to also do plus plus. Do this manually and see if it does anything. There's the seg v again, so seg fault. So it's doing nothing different than before. Let me just do this inline here. So we're going to copy the implementation of DA assert here into Sema. It is an invalid pointer because I'm not zeroing the memory in here. So, I mean, like, that just means it's not doing the copy. What I've determined is this is not copying to the correct location. It might have a way to inline the macro invocation. I've never tried it. If I kill this, try this, make this tiny, make this tiny. Not that I can see. LCADS. So grab these handfuls of lines. Oh, 1, 2, 3. So then every instance of this, first this needs to be LCADA set count, and the thing that we are DAing is this to LCADA count this plus 1. So then that's fine. LCADA count of this again. So then instead of calling this I, let's call it J, because we already have an I format to get rid of all the spacing. J. Because it's in the same memory and I don't know how memcopy is going to handle overlapping. Mem-move, maybe, but I've never done that. Can I safely copy or move overlapping memory? Because it is overlapping memory. Okay, mem-move can overlap. Okay. Well, really quickly, because I just finished it. Okay, mem-move would then be destination. The destination would be this sub I plus 1 like that. The source would be dest sub I. Then it would be LCADA count. The count is first off size t of this again. Minus I. question mark. So if I'm at 0, 3 minus 0 is 3. If I'm at 1, 3 minus 1 is 2. So I think that's it. But then it has to account for adding the node, right? So if I'm doing this, we've added the node. So now we've got I plus 1. So if I've got 0, 1, 2, 3, and I want to insert something at index 1, then that's 1, 2, 3. 3 minus, so the length is 4, minus 1 is 3. But after the insert, right, then it's 5 minus 1 is 4, but I want it to be 3. So it's the same thing minus I minus 1, right? That's the mem move, and this is the whatever. So if I set the breakpoint right here, bonk, somewhere up here, this line, what we should expect is for count to go to 4. Does it still segv? It does. Why? Run. So again, count is 3. Step over, count is now 4. The memory hasn't changed because we've allocated 32. So then mem move should give us, there's nothing new there. Does it zero out the previous one? Doesn't do anything. Nothing has changed. And then this will turn it into an array here. But this still doesn't exist. Why not? Why is that not? To mem move, it's wrong, you're right. It needs to be bytes, not elements. But the previous one was still wrong. So size of the value at here times that. So rebuild. Still a segv. Why is it a segv? So again, 332, more than enough space. We haven't used this slot yet, so it's still there. We expect this to get updated if the mem move happens. 4. Now it does. And then if I step over again, that's an array. So that looked correct. Then there should be no padding here. It went one time too many. Now I'm confused again. Run. So our I here is I at 1, which is the thing we're inserting. We've now decided that this is all good. But our count is now 5. Because I called insert a second time. So now this looks good. Now this one's not going to trigger padding. But then we hit this again. We went out of bounds again. Why? Wasn't paying attention like I was supposed to. So again, I is 1. We expect this to be 2 before we get to the thing. The array count, I have no idea what the array count is actually, but it's this, it's 3. So here, set count to 4, mem move set. Count is still 4. I is still 1, which is here. But now we want it to be 2. But the count went up. Oh, because I didn't recompile. I hate that it doesn't recompile. Okay, now we get back to type array. Now we're fine. Okay, so this needs to be the implementation in our header file. So we can go back to LCA DA set count of V to LCA DA count V plus 1. That is this. V plus 1. Cool. Then we want to mem move. So all of this shit becomes mem move reference to V sub I to reference V sub I plus 1 to, here's where all the math comes in. I think the problem was that you were doing greater than or equal to, not greater than. Because what I was doing in the loop, I think was right. Right, we're going to the new end, starting at the new end to everything but the element. And we're doing -1 here. Right, so we go with from, in our case of the original 4 becoming, or 3 becoming 4, we've updated it to 4 elements. So now we're going from index 3 down to index 1. Or down to index 2, because 2 is greater than 1. So 3 and 2. So at index 3 to 2, and then 2 to 1, and then 1 is unchanged because 1 gets changed here. So this is 1, 2, and 3. Which should be correct, which is why I was confused. But since it's not correct, I'm just going to move on. Okay, so now we've got this. Then we want this whole thing to make sure it's a size t. But we're going to do size t in here because we're going to have size of v times... and really, I think this is technically what we want. That's what we're doing up here. Size of, so size of v times size t of something. And that something is the difference between the current count and I -1, right? Well, I hate that formatting, but it's fine. So if we come back over here, that was size of the thing. Count minus I minus 1. Count minus I minus 1. I would still love if that formatted how I want it. But it looks like a cast to it, I guess. So I don't know what to do about that. Then v sub I is e, and v sub I is e. So this should do the exact same thing and still work. But I get the seg v again. We just got it to work. Right, so if I copy this one more time, everywhere that we see this becomes v. Right? Then everywhere we see this, which is kind of a pain, becomes capital I. Everywhere that we see padding field becomes E. This goes into here, paste. Well, now it works. Okay. So there we go. We have our insert. Insert now works. Okay. Make this tinier again. Get rid of this. So now we have padding in our thing. So then the final thing I want to do is cache this value. Laye.h. So type struct down here. We need int cached size and cached align. We're going to let Sema handle caching these. So this is node. Again, it's a type struct. So node type struct cached size is current size. And then cached alignment is this. Is current alignment. Like that. So then we can go into Laye data. And when we ask for the size of, or the alignment of, so this is align in bytes of the struct. If node type struct dot hashed align is not equal to 0, but is equal to 0, then this is the case. This is the case where we want to just return it. And then we're going to note Sema is responsible for caching. Anytime before Sema, we don't usually care about the size that much. This is most likely for debug use. Fine, not. So then we can come up here. Still work. Cool. Assertion false and unreachable for size in bits. So type size in bits. For what? Type array. Okay. Then let's return align to the alignment of the array. The size up to the alignment. We really just want the alignment of the element times the size. Right, so return align in bytes of type times 8 because we're in bits in size mode times the evaluated constant value if it exists. So we need to say int element size is this. Then I think I remembered what it was. In case anyone's interested, what is this return? Let me copy the entire thing so I can read it. Okay, so that's which is 1. but then the size of 0 becomes 4. So then 4, this is 2, this sub 4. So it's either of those two, but if it's 1, it's the logic I just went through, because this is the expression. Size of takes an expression. And this expression with 2, 3, 4, 5, because this wouldn't make sense, that would crash. That's, I mean, the size of 4, I guess it wouldn't. Then it would be like 0 instead, like uninitialized memory. Regardless, that's not a compile time operation. In this case, this is the expression. This is the equivalent of this. So the size of the 0th element of a string is a character. The size of char is 1. I know how C works. Yeah, strings are null terminated, but 4... Yeah, 4 would be the end. I thought it'd be 1 past the end, so that's fine. Element size. So it's either 0 or 1, depending on how you parse it, but I know how it's parsed. I know how size of works. I tried to write a C parser, and I already kind of knew how C worked. I've learned how C works. I'm smart. Okay, so we want int constant value to be a thing. We're going to make it 1 by default? Question. Well, we're in size mode. We could just say the size. We have no idea for a while, but size can just be times 1 in the meantime. If for int I 0, count is array count of type node, type array, type container, length values. I is less than count I plus plus. Then we can say Laye node count value or length value is this sub I, and then if length value time is equal to node eval, and god damn it, and length value evaluated constant result kind is equal to eval int, then we want constant value times equals the evaluated result int value. And it's an int 64 in that case. So then we just want to downcast this all to int and hope that it's not crazy big. And that's our size in bits for an array. And if it's not already semmed, then I don't care about the result. Okay, so then no such member x, y, and x is now wrong. Which is great. Okay, semma. Because now the type size in bytes here. So let's step through this. So we have member offset is 0, right? Cool. We have our struct type node here. Let's step through. Shouldn't that be underscore size instead of a line on line 420? In the type, no. In here, because it's an array, the alignment of the type determines where we're, like, it has to be aligned on a boundary. So two things next to each other inside of an array have to be aligned properly, right? So if the size of something is 7 bits, its alignment is probably 8 bits. So we're putting every element of the array at every align bits, or bytes in this case, right? So if its size is half of its alignment, then we're going to get misaligned. You're right, it doesn't tell me the size of the thing, but it's the size of the slot of the element. So the actual element size is the size, but within the array, I have an array of structs that are 64 bytes, but aligned to 8 bytes. Yes, so I should actually take the size and align it to the alignment in bytes. So align to size in bytes. That makes more sense. Why not? I mean, it should be, but what if it's not? Because what if this is not a struct? Right? We don't know what the element type of the array is. It might not be a struct. Right? If somebody passes in I-23, that should probably be aligned to 32 bits. So if I ask for the size of an I-23 in bits, I'm going to get 23. But an array of I-23s should be aligned to 32. Or are you saying that I should always have everything return something aligned to its alignment from everywhere? Should I-23 return 32 as its size? Because I guess when it gets aligned... Yeah, it will. If I ask for size in bytes, it'll return 32, which is this, I guess. Yeah, for bytes, that's just going to happen. I don't know if we're going to have this problem at the byte level, but this is a thing that returns bits. So I mean, but this is asking for the thing in bytes, so I guess that's fine if I just ask for the size in bytes. Times 8. Anyway, so... but it's not type, it's type node type container element type. Okay, so now we're back in IR. That's all good. Gober! Okay, so back in IRGen. We now are hitting false on something. No, we're not in IRGen, we're in type size in bits. Assertion type node module not equal to null failed. What? Type node type int module is 0. But the context isn't. So I should probably just be using the context. Because we don't care about module context. We're not even using it. Right? We're just grabbing the context from here anyway. Okay, now we're back to no such member. So why isn't... Okay, so we were going to debug no such member. That's why we're here. So first field is named foo. Okay. Foo is going to have a member offset from 0 to 1. Oh, because we're not... Okay, so now we have to handle the padding. So this F should have no name, 0 name, 0 data, 0 count, 0 everything. But it's a type array. So then this should set our offset up to 8, total of 8. Okay, so then this F name is X. So our member name we're looking for is X. F name is X. This should work. Member type is whatever. we haven't changed the offset anymore, and we're breaking. So our member offset is 8. Oh, but we're in bytes, and then type size in bytes for our value type is probably wrong. So break takes us here. If I go in type size in bytes, go into type size in bits, I'm probably returning the thing wrong. Hold on, I know what's going on. This cached size needs to be times 8, because we're caching it in bytes, not in bits. So it was returning a way too small number. There we go. Now we're in IR Gen 1010, failing on member. Okay. Long ride to get here. Long ride indeed. But we're finally back to IR. Oh my god. It's 6 o'clock. I kind of only planned for this to be a couple hours long, and we've been here for 3 hours. I might have to go take a break. All right. But all I have to do is generate a pointer add. If I can generate a pointer add successfully, then we're done, I think. Oh boy. So in order to generate a pointer add, we need some things. Let's do some assertions. IC value star address. That's going to be YSE generate, I believe, build, YSE build, no, IR, Laye generate. That's what I'm looking for. Generate node, in builder, node member value, this address, assert, type is pointer, value type, address. It also not be null. Okay. Right? So that's that. Let's also just get ready to return a pointer add. ISC build pointer add. Builder node location. Address. And then we need the offset value. This should probably just be offset as a value. So then we have int offset. So we have node member offset, which should be an int64, I think. int64t member offset. I'm just gonna store here so I don't have to find it later. Assert member offset greater equal 0. Then ISC value offset with Laye C build int or Laye C int constant in context, which does exist. This will be node location again, because it's just where it lives. The type will have to be probably just a regular int. Laye C int type in context. It'll be 64-bit int. That's fine. And the value is member offset. So then we assert that offset is not null. That is Discord. That is not my terminal. Okay. So now type struct in unhandled type in print toString in IR. So we're trying to print the IR and failing. So we have two things to do in the IR. Step 1, print the name of the struct. So type print toString. This is printing a value. This is printing a type. Okay, let's move array down somewhere else. Case Laye C type struct. So if this struct has a name, we want to print the name. If it doesn't, we need to print its literal value. So I probably want a separate function for printing the literal struct type, because I'll want that for struct declaration at the top anyway. So somewhere up here, oh right, this is the entirety of IR. I want just the printer. Global print, function print. So we should have, well, no, it's a two-string operation, so we'll just leave it inline down here. So we have type print two-string. We want a static void alliance type print struct type to string literal or something like that. I'll want it in the printer as well, but for right now we can just declare it here. So alliance type string s bool use color. Right, forward declare this at the top of the IR printer, so we can call it when we do declarations. So. No matter what here, we're going to do stuff. So to print a struct type with no name, a no-name struct type, we're going to print the keyword struct probably, so we'll start with that. Grab this, string append s struct. Then we need this. That's the color keyword. This will be color reset, right? And then at the very end, we print this, which needs color reset again, right? And what I can do actually is probably put the space here, not put the space here. Then for int I, int64 to I equals 0, I is less than type struct members. So this will be count, array count this, as less than count I plus plus. Then we have Laye type member type equals type struct members of I. We then want to type print to string member s use color, and we also want if I is greater than 0 to print a comma and space. Okay, then do that. So that prints a struct literal to string. So then here we just if type struct name count named, if struct whatever named, then we want to print the name of the thing. So that will be color name probably. Let's just grab this. Instead of pointer, it'll be mon.star_s. Color name and stir expand type struct name, like that. And it probably needs the sigil of every other name. I don't have that stored, but if it's a function, it's an at. So if it's a global variable, it's an at. If it's a global struct, then if it's a struct type, it should probably also be at, correct? At struct name, like that. Else this. Yeah, I'll stick with at and we'll just translate it to LLVM. So type s use color. Okay, so boom, we now have a leak, but that's fine, it's better than bad. So we haven't declared the struct yet, but that's fine. Allocate at vec2i, beautiful. Built-in memset 24, it's got the right size. Pointer add from this 8 gets us x, 16 gets us y, 34, 35. Do the loads again, return them. Everything else looks fine. I'm going to get rid of foo. We're done testing that. So we have 0, 8, 16. That looks good. So we have to implement translating none of this. I think if I were to LLVM this, aside from not declaring the struct, it'll probably not compile, right? Yeah, the struct. Okay, the struct type does still need to be printed, which is fine. We're just going to do this thing. So LLVM.c. LLVM type. Right. So then now I need to be able to get this stuff out of LUM. I don't have, it's opaque at this point. So Laye cd.h. We want Laye cd type struct is named. Laye cd type and then string view Laye cd type struct name. Laye cd type. Then int64t Laye cd type struct member count. Laye cd type and Laye cd type pointer Laye cd type struct get member at index Laye cd type int64t index. I think those 4 will give us everything we want. Yeah, my laptop fan kicked on. I don't know why. Nothing else is running in the background except for OBS, so it's just kind of decided it wants to be hot. Even though it's not, I'm touching the laptop. It is barely warm to the touch, which I guess is saying something. Normally it's cold, but yeah, I still haven't actually adjusted the fan curve like I want to, so. Okay, let me make this shit big. So struct type is name, return type struct, named, assert type not equal to null, assert type kind is equal to type struct. Easy. Okay, so then here, array count type struct members. Oh, fan's coming back. Just a little bit. Hasn't decided yet. It's gonna stay on. Okay, so then that gets me all my struct stuff. So then here, ISE struct type named. Type struct name. That's one. Type struct named. Type. Then instead of S, we want string append format code gen output this, and we're not doing any colors. No colors. Or expand. And coming back again. ISE type struct name. Okay. Otherwise, we want to do the same thing here and have a literal struct printer, a literal struct printer. So if I copy this and say LLVM print type struct, literally or something like that, then we'll use this, which will take code gen and type. So then what's the syntax for struct types? I don't remember. We're gonna have to find an example here. But if I do at least that, that gives us allocate vec2. Cool. So is it just declare like normal? I don't remember. Do I have an example on hand? I might if I go open up LCC. I think if I open LCC, I've got an example. I could generate an example. We can just go like temp. And we can, yeah, I mean, I can just do struct, say, struct vec2, int x, int y. And then we can see if that actually does anything. If we do lang s emit lvm o struct ll struct c and do fucking struct ll, does that give me my struct? I don't think it did anything because it just optimized it out because nothing was using it, so it's not going to be there. So if I struct c and we int main and return 0 and we do like, I don't know, struct vec2v, make sure it's got a value. There it is. So it's not a declare or anything. Declare a definer for something else. So we just do the name and it's type. Okay, that makes sense. So what we're looking for then is to append to the output the word type space and then this, and we decided the space goes there. So for int 64to0, I less than member count of type I++, member at index type I. We can then say Laye type member type is this, and we can LVM print type code gen member type, and then our final thing, if I is greater than 0, append a comma and a space. That. Okay, put in that. I don't need this anymore, I don't think. So here, it's again still going to do this. We still need to declare it, so we'll have to forward declare from our module. Not from the module, I guess. The module should probably declare every struct that the context uses. We don't have a way to know what module cares about it. So that's fine for now. I had the same problem in LCC, figuring out which struct types need to go where in LLVM. Without having a dedicated LLVM library tell me. So we need an API from Laye to get access to the modules or the contexts' structures. We'll put context stuff for whatever here. So Laye type, Laye context get struct type at index, Laye context X, right? So then I'd need an I in 64T Laye context get struct type count. Laye context C context. And I would just put these at the top of the API above module stuff. And I'm only doing this for consistency because we have access to it. It's public. I just don't want to access it. Return array count context struct types, right? So assert context not equal to null, easy as. Return context all struct types sub I, like that. Assert index greater or equal 0 and index is less than this. And index. So then we can say print module. Print module will print header. Print header is declaring a bunch of stuff. So I'm also going to just do for int64ti equals 0. I is less than ISE context. Why doesn't it like this? Oh, because... Cool. Okay, ISE context gets struct type count context, and context is code gen context. I++, ISE type struct type equals ISE context get struct type at index code gen context I. That works. Then we want to say pen format a new line eventually, but we want to start with modulo and then the struct name, ISE struct type name, ISE type struct name. There we go. If it's named, of course, we'll have to do that check as well. If it's not named, we skip it. So the name is struct type like that, plus an equal sign. Then we can print type struct literally, which we'll have to forward declare code gen struct type plus a new line. So only if ISE type struct is named struct type do we do any of this. Okay, so then when we grab print literally, I'll just put it right above print type because that's easy. And that should give us everything we want. We're not doing it for the actual IR yet. Deadly signal. Where? In Sema? Oh, that's a breakpoint, that's why. Like, what? What? LVM print header 75. LVM print header 75. Why? Oh, because we're still printing IR. That's why. LVM. What the fuck? Couldn't put me in my own code? I didn't do a thing. Okay. Stir expand this. Okay, so now we have mod vec2i type i64. Okay, my formatting's a little off, but that's fine. So really quick then, if I just say, don't even do this, still a leak detected, but if I ls test Laye, we're looking for struct, there it is, and I test Laye struct, and I echo 69, that's struct. That's a struct right there, so we have two things to fix. Thing one to fix is close this shit so I can see again. God damn it. Thing one to fix is IRGen needs to do the same thing. So we're gonna just yoinky sploinky this stuff. Then wherever we generate the module, or whenever we're printing, right? This is an IR printer here. Where are we printing stuff? This is IRGen, that's why. Where's the IR printer? IR print. Somewhere here. Module print. There's the module header. This is for all the globals, so we should do all of the types first here. So instead of code gen context, we should just have module context. Module context. If it's named, we're going to say struct mod.star s, which is the struct name, that's fine. So then this output will be just straight up print context output. Okay, and then to print a struct literally, we want print literally. So the type, struct type, the string print context output, and use color, right? So then this is mod s color name. And this is mod s for color keyword. And this is mod s for color reset. And then mod s again, color reset. Okay. And then I do need to include, no, that's fine. So if I go back here, IR, and we say struct vector2i equals struct in 64 and 64. Cool. It did not properly. Let's change the formatting here. So no space here. With a space here. Then this just gets to be a space. Okay, then this is just wrong. That's part of that problem. This is color keyword color reset. That's also wrong. Cool. What about now? There we go. In 64, in 64. There's our struct type. Find exported main, entry, allocate the thing, memset the thing, do the thing. That looks correct to me. But calling it struct here should probably not be the thing, right? So we could define vec2i equals struct. Or we could just say struct vec2i, the thing. I think for now, I can change this later. For now, instead of calling this part struct, I'm just going to say define. Like that. So define vec2i equals struct, like that. That's my syntax. That's what I'm sticking to. So next, we have a leak sanitizer. In generate node, so IR 215, we'll start there. IR 215 in, hold on, IR gen 215. It's converting type something. That convert type is doing a maybe expand. So convert type 188 is, okay. We're not freeing our struct type, that's all. So in context, when we destroy the context, somewhere in here, array free something, like that. Boom. Oh my god, I think we did it. I think we have struct types. Okay. We'll call it code gen here. Something like that. Ooh. And then I guess what I should have done is non-test before I did everything else. 100%. And we haven't finished writing. The array test is wrong. The struct test has nothing to do to pass yet, so it's fine. But the array test has failed because it uses gep. That's right. Array. So here it's using gep in 64. We want pointer add this. And instead of being i64.2, it should be 2 times int64 itself, which would be 2 times 8 would be 16, right? If I did everything correctly. What is it outputting? Run IR tests. It is outputting 2. So I need to do the math to multiply this properly times the element size. So in IRgen, right, we did index here. So we've got this calc index value, but we also need a value for the element size. So here we're using element type and doing nothing with it. So we should say LYSE value, element size value. That would be LYSE constant int constant. In context, element type array, node index value type. Node location, something like that. Maybe that's fine. The type of this would be LYSE int type context 64. Really, this should be platform. I'll go back and fix that later. And then this would be the size of the type, LYSE size in bytes of element type, right, like that. Insert element size value. So then, everywhere that we're doing a length, calculate the index value is build add. We want to multiply whatever we're doing at the end of the day times this value. So then calc index value equals LYSE build mul. Or really, here's the thing. What are we looking at here? We're looking at pointer add 0, 2. Without doing constant folding, all we know is 2. I think, right? Let's go look at array. Right? All we're looking at here is 2. So instead of saying 16, which we probably could, that's technically not right with no optimizations on. So this needs to be something different. It needs to be the result of a multiplication. So yeah, what I'm going to do here is say calc index value equals build mul builder calc index value, the element size. And it needs a location. That location will be its node location. Okay. So then if I do this and I print the IR, it should give us some extra instructions. So mul2 1, then mul2 3. Cool. Then if I non-test, it's still going to fail. I haven't copied over, but array is still running. That's good. So then array is the only failed one. So we're just going to copy it from here. We'll start with entry, grab everything within entry. Copy, paste. That. Okay, test. Then we still have to go write the test for struct. Array still fits because abba-da-bubba-da-ba. Mia, stop stupid. I remembered this time, Surveyed. I didn't fuck it up. Alright, why is it failing now? Why is it failing now? Why is it failing now? So let's just, I mean, I can't, so I guess we're going to go open up the last test. Find array Laye. Oh, because I forgot to put the pluses. Now. Cool. That looks good. Oh, closed code. That's not good. So if I run knob run test Laye array Laye test Laye array. Could be 2. It is 2. Good. So that's good. Delete. Goodbye. I'm about to go as well now that we've got that fixed up. Git and commit Laye fix bug with arrays. Git push. Nice and clean on main. Oh boy, that means I can do so many more things with Laye now. That's exciting. Thank everybody for tuning in to me figuring out what the hell to do with my compiler. Get this smaller so I can see again, god dang it. If you haven't already, don't forget that I have a Discord. I don't actually have it in the description, so I don't know why I even said it. I need to add the link to the description. Can I code dot documents sub stream text info? There's the Discord server link. Cool. Edit. Add a Discord link to the description. Grab my description. I didn't remove the going to lunch in an hour. Refactoring with compiler more. Save. Didn't even change my description. Cool. There's that. Bunch of cool devs in here to talk to. You can talk to the development channel for development purposes. Look at this pretty diagnostic renderer that I need to learn how to steal. Look at me in the voice chat all alone. We're gonna leave that. Anyway, I'm gonna go fucking relax. I'm tired as fuck. Debugging hurt my head. Have a good night.